So good day, this here is our last video on tangents and norms. So we've been progressively getting more difficult with our questions. This one here is probably one of the most difficult ones you're going to get in terms of finding a tangent and a norm. So let's have a look at the question saying the normal to the curve y equals x squared plus 3x minus 4 at point P, where x equals -1, cuts the curve again at a point T. Find the coordinates of point T. So we know we've got some form of parabola, and we know that we've got a normal that's cutting this parabola at two different points. It tells us at one point where the parabola is cutting at x equals 1, and it wants us to work out, well, let's find out what the equation of that normal is first, so therefore we can actually work out where that second point lies, so we can label it as coordinates of t. A lot of information I'm talking about, but let's break the question down. Let's have a look and see how it all works. So one thing I notice from here first is that I've got x equals -1, but I don't have a y value. So let's find that y value first. So let's find the y1. We can do that by substituting x1 into this. So when x equals -1, we get -1 squared plus 3 times -1 minus 4. So what do we get in here? We get 1, take away 3, take 4, which gives me -6. So therefore, we get x is equal to -1 and y is equal to -6. So we've got our first points. We now need to work out, we need to work out what the equation of this norm is going to be. So we need to find the gradient to the norm. So let's find the gradient of the normal. So we need to differentiate this one. dy dx is equal to 2x plus 3. We've differentiated it. So nice, straightforward, simple differentiation. Now, when x is equal to -1, we can say when x is equal to -1, we can find this gradient of our normal. So therefore, 2 times -1 plus 3. So therefore we get the gradient of the tangent, which is going to give me 1. The gradient of the norm then will be the negative reciprocal. So -1. We now want to find the equation, so let's find that equation. So we'll write this here. Find the equation of the normal. Because all I know at this point is I'm going to have a straight line that's going to cut and this parabola at two different points. And I need to know what that equation is before I can actually go any further. So now let's use our rule. We got y minus, well, y1. Remember, this here is a minus here, so we can do -6 is equal to -1 brackets x minus -1. So let's simplify this up. Y plus 6 is equal to -x minus 1, because this gives me +1, but when I multiply by a negative I get -1. And then let's bring our 6 across. So we end up with y is equal to -x minus 7. So there is the equation to my normal. Alright. Let's sketch a curve at this point. Let's do a diagram of what we think this looks like. I know that I've got a parabola. So I've got y is equal to x squared plus 3x minus 4. Well, if I want to sketch this in a nice straightforward, I want to find out what 2 points I have. So let's break this down. Two numbers that multiply to give me -4 and add to give me +3. Well, let's have a look. What can we get? Well, we get positive 4 and minus 1. Let's see. 4 times negative 1 is negative 4. 4 minus 1 is positive 3. So therefore, we get the coordinates of negative 4 and x is equal to 1. Hang on, let me have a look. Yeah, it's got to be in this case. So we've got these points here. If we were going to sketch this graph, we'll just do a nice sketch here. I know I've got negative 4 and I've got 1, so I can kind of sketch this out. What else I know is that my normal has points of negative 1 and negative 6. So this here is point P, according to what I have. So if I was going to sketch this line through, and it's going to be here's your tangent. So again, if you drew your tangent in red, just so you can see that it's perpendicular, there is my normal going through here. Well, one way that I can solve to find what this point T is going to be is I can use simultaneous equations. And I've got two equations here. I've got the equation of this parabola and I've got this equation of my normal. So if we solve these simultaneously, so we'll have, and because they're both equal to y, I can do this. X squared plus 3x minus 4 is equal to negative x minus 7. Remember, the key here is to find out what my other x value is going to be here. So let's bring everything across. I have x squared, I bring my negative across, it becomes positive, so positive 4x. I add my 7, so I get plus 3, which is equal to 0. Let's now break this down, so we get two values that could equal to 0. So two numbers that multiply to give me 3 and add to give me 4. Actually, let's have a look. So in this case, I can get plus 3 plus 1. So therefore, x could either equal negative 3 or x could equal negative 1. Let's have a look back at our graph. Well, I can't use negative 1 because if I plug negative 1 into the equation, like I did over here, I'm going to get negative 6, and that's already point P. So I need to use x equals negative 3. So now, when x equals negative 3, I'm going to plug it into this equation, or this equation. It doesn't really matter, because I know that this point here, I've got negative 3. I need to find out, well, what is the y coordinate going to be? And because they're meeting at the same point, it doesn't matter which equation I'm going to use. So let's just use the smaller equation because it's nice and straightforward. So y is now equal to negative 3 minus 7. Don't forget that this negative doesn't take over this negative. That negative is already there, so you have to include it. So therefore we get 3 minus 7, which is equal to negative 4. So y equals negative 4. Now if we think about this, this makes sense. Okay, we've drawn the parabola and the normal here. We've got these in the kind of correct positions they should be according to the Cartesian graph. Here I've got negative 1 and 6. And this is continuing in a straight line through here at a normal to your tangent or perpendicular. Look where it's cutting here. Well, it's cutting at this point. So therefore it should be less than negative 6. In case it is negative 4. And it's cutting further away from the 0. So therefore it should be smaller than negative 1. It's negative 3. So we've found out that our coordinates for t are -3 and -4. And we've done that by a process of using our normal calculations to find the tangent or find the gradient of the normal, finding the equation of that normal, and then simultaneously solving those two equations because they're cutting at the same place. Alright, complex question. Takes lots of work. These questions are difficult because you have to think about what am I going to be doing. But once you break those steps down, I have to find a y-coordinate, I have to differentiate, I then have to find the gradient of that normal or tangent, find the equation of it, and then start thinking about what am I doing with that data. Alright, I'll see you next one. See you later.